Next, we are going to discuss about the result, maximum modulus principle. Maximum modulus principle states that if f of z is analytic and non-constant in a region omega, then its absolute value mod f of z has no maximum in omega. That is, for any non-constant analytic function f of z defined on a region omega, the modulus value of that function has no maximum in that region. To prove this, suppose if possible assume the negation of this statement, that is, if possible assume that mod f of z has a maximum in omega, say at some point z naught in omega, and let f of z naught is equal to w naught. Here f of z is a non-constant analytic function defined on the region omega, and omega is an open connected set. So by previous result, we can say that the image of omega under this function is an open set. Since omega is an open set, the non-constant analytic function f of z on omega maps omega onto an open set. That is, f of omega is an open set. And f of z naught equal to w naught implies that w naught is a point in this open set f of omega. So by definition of open set, we can say that there exists a neighborhood about w naught which is contained in omega, f of omega. Then w naught belongs to f of omega implies that there exists a neighborhood of w naught which is contained in f of omega. Let it be mod w minus w naught less than epsilon. Here consider this epsilon, and when we consider the point w naught plus epsilon by 2, this point will lies in this epsilon neighborhood of w naught, and we have modulus of w naught is less than modulus of w naught plus epsilon by 2. That is, here we can find a point w1 equal to w naught plus epsilon by 2 in this epsilon neighborhood of w naught, such that modulus of w naught is strictly less than modulus of w1. Okay, then modulus of w naught is less than modulus of w naught plus epsilon by 2, which is equation 1, and w1 equal to w naught plus epsilon by 2 lies in the epsilon neighborhood of w naught, and hence in f of omega, and hence this point w1 lies in epsilon neighborhood of w naught, and hence this point w1 lies in f of omega. Therefore there exists a point z1 in omega such that f of z1 equal to w1. Here this w1 lies in this epsilon neighborhood of w naught, and this epsilon neighborhood of w naught lies in f of omega, contained in f of omega. So we can say that this point w1 is in f of omega. So w1 belongs to f of omega implies that there exists a point z1 in omega such that f of z1 equal to w1. Then by equation 1, we can say that modulus of f of z naught is less than modulus of f of z1. This is a contradiction to our assumption, but we have assumed we have assumed that the function f of z has a maximum, the modulus of f of z has a maximum at the point z naught. So our assumption is wrong. That is, therefore, modulus of f of z has no maximum in omega. Okay, therefore, for any non-constant analytic function defined on a region omega, the modulus value of f of z has no maximum in that region. Okay.